Merci, Rick. Bonjour à tous. Hello, everyone. Sorry about that. I'll be presenting a summary of the progress of the Fox Creek project. This environmental study conducted in a region with significant industrial activities related to oil and gas, but also forestry, includes several components, but my presentation today will mainly focus on the work related to hydrogeology. So now I can't. Can I? Yes, okay, I'll just skip the abstract for the presentation. As you can see, more than 20 people are involved in this multidisciplinary and multi-institutional project, including 5 grad students. The study area is located in west central Alberta, just southwest of the town of Fox Creek, in between Edmonton and Grande Prairie, and it extends over 700 square kilometers. This area is mainly forested and unpopulated, so there are no residential or farm wells. The only water supply wells belong to oil and gas operators. Fox Creek was selected for this project because it has been one of the most active regions for oil and gas production in Canada over the last 50 years. Only in this limited study area, there are over 800 oil and gas wells. The regional bedrock aquifer is located in the Pascapoo Formation, shown in yellow here. This formation is the most important groundwater supply in the province. It is a non-marine unit that corresponds to a complex succession of interbedded mudstone and siltstone with sandstone channels, and that is known to contain some coal. The Fox Creek project had 2 objectives at the beginning. First, to characterize the regional shallow aquifer located in the Pascapoo. And second, the second objective is to investigate the integrity of the intermediate zone, which is located below the superficial aquifers and above the zone targeted by the industry, here the Duvernay Formation. This zone does control the vulnerability of shallow aquifers to potential contamination that could come from activities at depth. The third objective came a few months later when our government decided to add cumulative effects assessment to its priority themes. This year, 3 core wells were drilled very recently, in fact, in addition to the 9 monitoring wells that had been drilled 2 years ago using a conventional technique with which only cuttings can be obtained. The objective was to drill 2 shallower and 1 deeper wells next to wells drilled 2 years ago to obtain information on the vertical hydraulic gradient and the water chemistry, but also to obtain cores for density, porosity, permeability, and S&P wave velocity analyses, and as well as for rock geochemistry. The cores we obtained from the deeper borehole very well illustrate the great heterogeneity of the Pascapoo Formation and its highly variable degree of consolidation. Intervals of shale, mudstone, siltstone, and sandstone, ranging from very fine to coarse grain, were mainly recovered, but some bentonite and coal strata were also obtained. In addition, the presence of fossils, coal seams, and gouge was also obtained or observed in a few intervals. And some sandstone intervals at various depths and in between well-consolidated intervals showed little or no consolidation, suggesting that large amounts of water may have leached the cement or intergrain matrix or may have prevented it from forming. This is important information because vertical recharge across the study area is low. Therefore, this would indicate that much of the water comes from outside the watershed. More analysis will be performed, of course, in the upcoming months to test these assumptions. Because very large amounts of water were required during drilling, groundwater from these 3 new wells could not be sampled immediately after the drilling campaign, but sampling is planned for this winter, and same for permeability tests. Also, as part of a new master's thesis on vegetation recovery in areas impacted by oil and gas development, the student and her advisor recently conducted an initial identification of the current vegetation on old oil and gas well paths. And as part of a master's thesis on the estimation of water budgets in both disturbed and undisturbed areas, monthly visits to 5 paired sites have been conducted over the past few months. The work includes collecting data or samples from lysimeters, soil moisture sensors, rain gauges, and rain collectors on frost-free days, and from the snowpack to obtain density, thickness, and chemistry during the winter. Data from 4 weather stations installed by the student are also available. I'll now present some of our recent results. As there was practically no data available for the study area on superficial sediments, Guelph permeameter tests and grain size analysis were performed on samples from the drilling of monitoring wells and the master's project on water budgets. Results confirm that the superficial sediments contain a lot of fine particles. In general, more than 70% of the particles are smaller than 63 micrometers. The Kozeny-Karman method provided hydraulic conductivity values in the order of 10 to the minus 7 meters per second, confirming the results obtained in situ with the Guelph permeameters. Recharge has been estimated using a few methods, but the range remains very uncertain. A gauging station was first installed on Tony Creek, the main stream in the area, in September 2020 as part of this project, but a variety of issues occurred every year. So values for recharge mainly come from a provincial report from a rough water budget, because most weather stations in this area have many data gaps and short time series, and data also come from hydrological modeling. We also use a gauging station draining a much larger watershed to obtain an estimate. And in fact, they all provide relatively low annual values ranging between nearly 0 and 80 millimeters per year, in agreement with the large fraction of fine particles in superficial sediments. However, the master's project on water budgets will greatly help us better understand the behavior of this parameter for water. It's a key parameter, in fact, for water management over the course of a year, and I would say in general. Geophysical logging of the first series of monitoring wells indicated, among other things, that fluid pathways were mainly along discontinuous fractures, but also through the sandstone matrix, which was confirmed by the recent core drilling campaign. The poorly consolidated rock of the Pascapoo Formation caused wall roughness and cavities during the first drilling campaign, and you have a nice example here, affecting the estimation of various parameters, especially geomechanical. So the analysis of some of the new cores will help support the interpretation. Groundwater from most wells is of the sodium bicarbonate type, shown in pink here, but a few wells located upstreams or that are shallower or that have more permeable overlying units have a calcium bicarbonate type, shown in green here. Surface water samples are all of the calcium bicarbonate type. As these samples were collected during the summer, this suggests that the streams are mainly supplied by local groundwater during this low flow period, likely indicating that the older groundwater would not discharge in these streams. Thus, we believe that there would be 2 distinct systems in the freshwater Pascapoo aquifer: a local, shallow, unconfined system, probably from 0 to 30 or even 50 meters deep, that is connected to the hydrographic network, and a less local, deeper, confined system that is disconnected from the streams. This is also supported by water level data from our wells and statistics from the provincial database that show that the mean static water level in wells across the study area increases with the well depth. Also, based on the fact that high yields are available, vertical recharge is low, some sandstone intervals are barely consolidated, and the fact that we found large uncorrected radiocarbon age values generally greater than 10,000 years, which is quite unexpected for this relatively small watershed. We believe that a significant contribution of water would come from the Rocky Mountains. Only 7 wells were found to contain small concentrations of dissolved methane, all of microbial origin. This methane is probably associated to the presence of coal that was often observed during drilling. The collection of isojars during the drilling campaign will help us confirm this, or not, we'll see. A 3-dimensional hydrogeological model was developed in FEFLO based on the provincial geological model for both bedrock and superficial sediments. This model is about 1 kilometer thick and also includes superficial deposits, which are typically relatively thin, less than 30 to 40 meters. Median hydraulic conductivity values for the various geological units and constant recharge rate were used in the model based on values obtained from our field and lab work and the provincial reports and databases. However, some heterogeneity was added to the upper part of the Pascapou Formation using zonations while remaining within the range of plausible values for this unit to be more representative of available hydraulic conductivity values and thus better match simulated and measured hydraulic heads, and to also avoid losing streams as well as flooded areas that are not representative of reality. The difference between the simulated and measured water levels is considered relatively good with a root mean square error of 6%. The understanding gained from this relatively simple model will help in the development of a coupled surface water or groundwater model, which has already started. Finally, the ongoing study on the evolution of landscape over time clearly shows that today the deciduous forest occupies a much larger area than it did in 1949. Although it is difficult to distinguish conifers from deciduous trees in the old photos, I was told, so it is not possible to obtain to quantify or to obtain a certain percentage. But this change is likely due to a combination of factors, including increasing human activities and changing climate. The extent of wetlands and bogs has decreased, while the extent of cut blocks or cutting of the forest has, of course, significantly increased for roads, oil and gas well pads, seismic lines, and pipelines, making caribou, among others, very vulnerable. Thank you very much.